Professor Pelton. This is Algebra 2, Chapter 6, Section 4. We're doing transformations of exponential and logarithmic functions. The exponential come first, logarithmic comes second in this section of the chapter. Keep in mind in the previous first three chapters of the book, we did transformations, and you can look at the back of the transformation rules given on each of the chapters. So in general, they use f of x for the name of the function that's being used. And we do these for many different functions. So adding and subtracting shifts it down. So that's a translation up and down, add, subtract. If the adding and subtracting is in the inside, then it goes left or right. Counterintuitively, add is actually left, subtract is actually right. Changing it by a negative changes either your x or y value. On the outside, changes your y value, and your inside changes your x value. If you change your y value, you go over the x-axis. If you change your x value, you go over the y-axis as a reflection. And then lastly, multiplying is scaling. Multiplying on the outside changes y. Multiplying on the inside changes x. Right, so multiplying on the outside versus multiplying on the inside. One changes y, one changes x. Okay, and it's counterintuitive in the inside. So anything greater than 1 is actually shrink. Between 0 and 1, fractions and decimals are going to be a stretch. On the outside, it's straightforward. Keep in mind when doing multiple transformations, the order of transformations still applies. Horizontal translations first, scaling, which is stretching and shrinking, comes second. Reflection is third. Vertical translations is fourth. Okay, so specifically in this section, we've rewritten it such as if you just have the parent, which is b to the x, so none of the other components are on there. The other components tagged on do the translations, but now we've replaced f of x with the b of x for a specific exponential function. Okay, and the inside now is actually the exponent itself. Those have assumed parentheses. Okay, that is the inside, which affects the x nowadays for this function. Okay, so let's do this here. So the parent of 2 is 2 to the x here. So 2 to the x power is our parent. So we did an xy table, -2, -1, 0, 1, 2. 2 to the -2 is 1 over 2 to the second, which is 1/4. So you get 1/4, 1/2, anything to 0 power is 1, 2, then 4. So if you graph those, you're going to get the various points, but the only ones that are nice whole numbers are 0, 1, 1, 2, and 2, 4. So I don't want to move around the ones that are fractions, so I'm going to keep with those ones there. So as you see, this graph has an asymptote at y equals 0. Okay, so the x value changes, but the y is always the same for these. So if I minus 3, that's on the outside. That is a vertical translation. So everything moves down 3. So I'm just going to move each of these points down 3. So the 0, 1 point goes down 3 and becomes 0, -2. That one goes away. The 1, 2 point goes down 3 and becomes 1, -1. And the 2, 4 point goes down 3 and becomes 2, 1. Okay, so we'll get rid of these points here. You can do more points if you'd like, because obviously this also goes to 3, 8 if I continued on with the table. 3, 8, right? 2 to the third power is 8. And if I went to 8, that would go down 3, 1, 2, 3. So that would eliminate this point because it moved down 3. And that would give us a value of 3, 5. Okay, so we have a graph that goes like this. And it is going to bottom out down here, but the question is, where is it going to bottom out? Well, it's going to bottom out in a dotted line, which is the asymptote of y equals -3. That is the asymptote. So the asymptote actually moved because the whole function moved down. So either way, I can plug in anything I want and go to negative infinity to infinity. There's infinite possible x values that I can plug in. However, no matter what I plug in for 2 to the x power, I'm not going to be able to get negative or 0. So the best I can get to is -3, but I can't actually get there. So that's our domain and range. All right, let's flip the page and try the next problem. And again, if you don't remember the transformation steps, look back at the previous page. So again, 2 to the x, same as the prior page. We're going to use the easy points, which are 0, 1, 1, 2, 2, 4, and 3, 8. That seems good enough. So if we look at this is our parent right here. So our new function has a +1, which is a vertical translation or shift up. This -2 is a horizontal translation right, because it's counterintuitive in the inside. Remember, the exponent is in parentheses. That's an assumed parentheses. That is our inside for exponent type functions. And then we have this negative out front, which is a reflection in well, if it's on the outside, it affects y. Inside affects x. So if it affects y, I changed my y value. Therefore, I went over the x-axis. So if you go back and review the order of operations, or i.e. the order of transformations, which ones of these happen first? Well, the horizontal translation happens first. The reflection happens second. The actual second thing in the table is scaling, but we don't have any here. And the last thing is the vertical translation. So we'll take the first point, 0, 1, and we have to horizontally translate right 2. Then we have to reflect over the x-axis. Then we have to translate up 1. Okay, so that is the new location of our point 0, 1. Now we'll take the next point 1, 2. And we do the same thing, horizontal translate right 2. We have to reflect in the y-axis. And we have to go up 1. Oh, I erased the wrong point there. Okay, next point is 2, 4. 2, 1, 2, 3, 4. We have to move right 2. Reflect over the x-axis. And shift up 1. Okay, last point was 3, 8. So I'm going to 3 up to 8. We're going to shift right 2. We're going to flip over the x-axis. And we're going to vertically go up 1. Okay, so it looks like our graph is going down because of the reflection. The question is, what is it going to go up to? Well, the answer is 1. Okay, it's going to go up to this line 1, but it's not going to be able to cross it because originally the asymptote is y equals 0, right? The x value changes in that line, but the y value does not. So that is the equation of the asymptote. So in this one, since we had a 1 that vertically shifted it up, this is now a y equals 1 asymptote. Abbreviate there, can't quite get it in. So you can still go to infinity in both directions, positive and negative. You can't get there, of course. However, the best I'm going to do is get up to a positive 1, but go down forever. So the highest I can get is 1, but I can go down forever. So that is our new range for this problem. Okay, pause the video, try the student problem. Okay, student problem. We have 2 to the x again. So our points are 0, 1, 1, 2, 2, 4, and 3/8. So there are other ones, obviously, but we'll take the nice whole number ones and go from there. What are the components of this transformed function? We have a translate down, this positive one up in the parentheses, or the i.e. the exponent, is translate left, because it's a +1, so it's counterintuitive in this case. And the negative is in the inside, because it's inside the parentheses, i.e. the exponent in this case, which is considered the inside for this type of function. So reflects, can we get the E in there? Reflection in the, well, if it changes the x value, that means I reflect it in the y axis. So we're going to take the point 0, 1 first, and we're going to need to go to the correct order, which is left to right horizontal translations first, reflections come third, but second on this problem, and translations down third. So we're going to translate left 1. We're going to reflect on the y-axis, and we're going to translate down 1. Okay, so that is our new point. So we'll take our next point, which is 1, 2, and go in order here. We're going to translate left 1. We're going to reflect on the y-axis, but it's already on the y-axis, so I can't go anywhere. And then translate down 1. Okay, next 2 points. The next point is 2, 4. We're going to translate left 1. Reflect over the y-axis. And translate down 1. Okay, so lastly, our new point is our next point is 3, 8. 3, 1, 2, 3, 4, 5, 6, 7, 8. We need to translate left 1, reflect in the y-axis, and we need to go down 1. Okay, so that makes our new set of points, which are -2, 7, -1, 3, 0, 1, and 1, 0. Okay, so we have this graphic that kind of goes like this. So what is it going down to? Well, since this translated down 1, this is now y equals -1, because the original is y equals 0. So it's going to go down like that. So I can go forever left and forever right. However, I can only go down to -1, but I can go up forever. And that is the end of part 1.